Welcome. This presentation is an introduction to SQL Log Management. We'll be exploring how to track changes and manage logs in SQL databases. This is essential for maintaining database integrity, security, and compliance. So, what exactly is SQL Log Management? At its core, it involves several key components. Firstly, it's about tracking database changes, knowing exactly what has been altered within your database. Secondly, it includes capturing SQL operations, which means recording all the SQL commands that are executed. Thirdly, it involves recording data modifications, every time data is added, updated, or deleted. This also includes monitoring user activity to see who is accessing and modifying the database. Finally, it is about maintaining audit trails, which serve as a historical record of all activities. Together, these components provide a comprehensive overview of your database's activity. SQL Log Management is very important for several reasons. First is security. It helps detect unauthorized access and suspicious activity, protecting sensitive data from breaches. Second is compliance. It helps you meet regulatory requirements like General Data Protection Regulation, Health Insurance Portability and Accountability Act, Sarbanes-Oxley Act, and Payment Card Industry Data Security Standard with detailed audit trails. Third is recovery. It enables you to restore data to previous states during incidents and understand the sequence of events leading up to them. Fourth is troubleshooting. It allows you to diagnose and resolve database issues by tracking the origin and impact of changes. Fifth is auditing. It helps track who changed what, when, and how, maintaining accountability in database operations. Sixth is performance. It enables you to identify optimization opportunities by analyzing query patterns and execution frequencies. Let's explore the common methods used in SQL logging. One such method is database triggers. These are automatic procedures that execute when specific events occur in the database. Triggers are ideal for automatically capturing data manipulation language operations like insert, update, and delete. Here is an example. The code creates a trigger named log_customer_changes that activates after an update on the customers table. For each row that is updated, it inserts a record into the customer_audit_log table, noting the user ID, change date, operation type which is update, and the old and new email values. Another common method is using transaction logs. These are built-in system logs that record all transactions and changes made to the database. Transaction logs are very important for recovery operations and maintaining database consistency. The first code snippet here shows how to back up SQL Server transaction logs to a disk. The second code snippet shows point-in-time recovery configuration in PostgreSQL. Let's continue discussing the common methods used in SQL logging. One such method is audit tables. These are custom tables designed to store historical changes to data. It provides detailed tracking of who changed what and when. The SQL code here creates a table named employees_audit. This table includes fields for audit ID, employee ID, who made the change, when the change was made, the operation type, and the old and new data stored as job objects. Another common method is using change data capture, abbreviated as CDC. It is a technology that captures changes made to database tables. It only tracks the changes rather than entire records, thereby improving performance. The first code snippet here enables change data capture on a SQL Server database. The second code snippet enables change data capture on a specific table called customers within the DBO schema. Once we have the logs, it's very important to choose where to store them. One option is to store logs in database tables. This involves creating dedicated tables within the same database to store log data. Using database tables makes it easy to query logs using standard SQL, and it maintains referential integrity with the original data. The advantage of this storage option is simple implementation, immediate availability, and transactional consistency. The disadvantage is, It can impact the performance of the production database and increases storage requirements. Another storage option is flat files. This involves storing logs in comma-separated value, JavaScript object notation, or plain text files. This option has lower overhead than database storage, and the files are easy to archive and transfer. The advantage of flat files is minimal impact on database performance and flexible storage options. The disadvantage is more complex to query and potential for inconsistency with the database state. The other option is using a separate database. It is a dedicated database for log storage, where you can isolate logging from the production workload, and it can be optimized specifically for logging. The advantage is separation of concerns, minimized production impact, and scalability. The disadvantage is additional infrastructure costs and complexity in setup and maintenance. We can also use specialized log systems. These are purpose-built logging solutions. These include Elasticsearch, Splunk, or cloud logging services. These specialized logging systems provide advanced search and analytics capabilities. The advantage is advanced analysis tools, scalable architecture, and visualization options. The disadvantage is licensing costs, learning curve, and potential integration challenges. Let's see an example of how to implement audit logging in SQL. Here is the SQL code to create an audit table named audit_log. This table will store information about changes made to other tables, including the table name, operation type, record ID, column name, old value, new value, who made the change and when it was made. Here is the SQL code to create a function to write audit logs. The code creates a function named audit_trigger_func that will be triggered on insert, update, or delete operations. It captures the old and new row data as JSON and inserts a record into the audit_log table with details of the change. Here is the SQL code to attach triggers to tables. The code creates triggers on the employees and customers tables that call the audit_trigger_func function after each insert, update, or delete operation. Finally, here is the SQL code to query audit logs. It provides sample queries to view recent changes by a specific user and to find all changes to a specific record. Now let's discuss some of the best practices in SQL log management. First is define retention policies. Establish clear policies for how long different types of logs should be retained based on business needs and compliance requirements. It is important to note that different log types may need different retention periods. For example, security logs may be kept for 1 to 2 years, while transaction logs are kept for 30 to 90 days. Second is selective logging. Log only what matters. Focus on capturing meaningful changes and limit verbose logging to reduce storage requirements and improve performance. Consider logging only security-sensitive operations and data modifications, not read operations. Third is secure log access. Implement strict access controls to protect log data. Logs often contain sensitive information and should be treated with the same security as production data. Use role-based access control and encrypt sensitive log data both in transit and at rest. Fourth is include user context. Capture who performed each action by logging user IDs, application names, and connection details for complete accountability. Use application-level user IDs rather than database users when possible to provide better business context. Fifth is implement log rotation. Set up automatic log rotation to archive and compress older logs, freeing up resources while maintaining historical data. Consider time-based, that is daily or weekly, or size-based rotation strategies, that is when logs reach a specific size. Sixth is monitor log health. Regularly check the health of your logging system to ensure it's functioning correctly and not impacting database performance. Set up alerts for unusual log growth, failed logging operations, or excessive logging activity. While SQL log management offers many benefits, it also presents some challenges. One challenge is performance impact. Extensive logging can significantly impact database performance, especially on high transaction systems. To mitigate this challenge, use asynchronous logging mechanisms, log to a separate database instance, implement selective logging for critical operations only, and consider using change data capture for high-volume systems. Another challenge is storage requirements. Log data can grow rapidly, consuming large amounts of storage space and increasing costs. To mitigate this challenge, implement log rotation and archiving strategies, use data compression for older logs, define and enforce log retention policies, and consider storing only differences rather than full records. Another challenge is query complexity. Extracting useful information from log data can be complex, especially for temporal queries or analyzing patterns. To mitigate this challenge, create index views for common log queries, implement a data warehouse for log analysis, use specialized log analysis tools, and develop standardized reporting procedures. Another challenge is consistency issues. Maintaining consistency between log data and actual database state, especially during schema changes, can be difficult. To mitigate this challenge, store schema version with each log entry, use flexible storage formats like JSON, log schema changes as part of database change management, and implement version-aware log retrieval mechanisms. Finally, let's look at the future trends in SQL log management. Artificial intelligence-powered analysis will be used. Machine learning algorithms will increasingly be used to analyze SQL logs, detecting patterns and anomalies in database activity that would be impossible to spot manually. Predictive analytics will enable proactive identification of potential security threats and performance issues before they become critical problems. Real-time monitoring will also be seen. The future of SQL log management will see a shift toward real-time monitoring and alerting, moving beyond historical analysis to immediate response capabilities. Streaming analytics platforms will process log data as it's generated, enabling instant insights and automated responses to critical events. Distributed ledger technologies will also be used. Blockchain and other distributed ledger technologies will be integrated into SQL logging systems to provide tamper-proof audit trails for highly regulated industries. These immutable logs will offer cryptographic proof of data integrity, creating a verifiable history of database changes that can satisfy stringent compliance requirements. Containerized log management will also be seen. As database deployments increasingly move to containerized environments, log management solutions will evolve to handle the ephemeral nature of containers and microservices. Next-generation log aggregation tools will capture and correlate logs across distributed systems, maintaining context even as containers are created and destroyed. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.